What's up, team? Welcome back to Fantastic Chemistry Podcast. My name is Pete. I am your host. Tusky is my co-host, and we're ready to go on to Chapter 9. Here we go. This Chapter 9 will dedicate the entire chapter to talk about covalent bonds and molecules. All right, this chapter is just a covalent compound. We encountered a lot of covalent compounds. Before we get into the detail, I found this on the internet. Take a look. The internet said that there's a baby in this picture. Can you see it? I'm going to leave this picture right here, and I'll give you the answer later. Okay. Let's see if some of you can spot the baby in here. All right, now let's go on to chapter 9. So let's review real quick. So there are three types of bonding. So chemical bonds, we have ionic bond, we have covalent bond, and metallic bond. So now we're going to spend time talking about covalent bond. Okay. Now let's start with the covalent bond of these atoms, these elements. All right. All right, we're going to put them like here on the left side. So carbon, if you remember, so carbon is group 4. Group 4, so this guy has 4 valence electron. Okay. So carbon group 4, so 4 more electrons will become octet, which is stable. So carbon will put out 4 valence electrons separately, not together as like a lone pair, right? All these are unpaired electrons, which is reactive. And reactive so that each of these will go find another electron to pair. And that's the reason why carbon will most of the time end up as 4 bonds. That, so that's 8 electrons carbon, right? So 1, 2, 3, 4, 5, 6, 7, 8. Right? So what I want to say is an unpaired electron is reactive. Each unpaired electron will go find a partner, okay, to form 4 bonds basically. So carbon will form 4 bonds. Now nitrogen group 5, so 3 more electrons will become octet. So I need 3 more. So nitrogen will put out 3 unpaired electrons. That. And the other 2, so 5 valence electron, the other 2 put them as a lone pair. And lone pair is less reactive than an unpaired. You might have heard the word radical, and every time when we heard about radical, it's usually in a negative term because it do something with your body, like anyway. So this is actually a radical, right? An unpaired electrons is another name is radical. It's really reactive. All right. So for this reason, nitrogen usually form 3 bonds, right? And each one of them have 1 lone pair left. So this lone pair, so this lone pair, this lone pair, all of them form 3 bonds. Ammonia, nitrogen, this is nitrate. Okay. All right. Next one, oxygen. So I'll have you guess now. So I'm talking about Lewis symbol right now here. Lewis symbol of carbon, Lewis symbol of nitrogen. Now oxygen, group 6, so 6 valence electron. 2 more become octet. How many unpaired electrons does oxygen has? 2 unpaired, right? So 6 valence electron, 2 unpaired, and then 2 lone pair, so 6 electron total, right? That's the reason why most of the time oxygen form 2 bonds, and each one of them got 2 lone pair left, like in oxygen gas and water. Group 7, so 7 valence electron. So need one more electron to become octet. So all these fluorine, chlorine, bromine, iodine, they'll put out 1 unpaired electrons, right? 1 unpaired electron. So they will form only 1 bond, like in Teflon. So like each fluorine form 1 bond with carbons, all right? Hydrogen. Hydrogen is the smallest atom, got only 1 electron in it. So this guy it has only 1 electron. You can't make a pair, right? So hydrogen will form only 1 bond. And neon, guess what? Group 8 valence electron. All of them are unpaired. So all of them are lone pairs. That's the reason why neon doesn't do reaction. So because it's all of them are lone pair. No an unpaired electron. All right. So these are Lewis structure. Carbon, nitrogen. So group 4 we act like carbon. Group 5 will be like nitrogen. Group 6 will be like oxygen. So the same group, they do the same thing. Now, since carbon has 4 unpaired electrons, the bonding capacity is 4. So each one of them go form a bond. Right? Find another electron from a bond. So that's the reason why carbon form 4 bonds. Nitrogen 3 unpaired, 3 bonding, 3 from 3 bonds. Oxygen 2 unpaired, So 2, and fluorine, just 1 bond, right? Hydrogen, just 1 bond, and neon, 0, doesn't form any bond. Right. The number right here we call bonding capacity, which is the number of covalent bonds an atom is capable of forming. Okay. All right. So just super simple right here. Pause the video and answer question right here. Draw a Lewis symbol for each of the following atoms and determine their bonding capacity. Well, look at the group here. So bromine group 7, so 7 valence electron. The bonding capacity is just 1. Need 1 more to become octet. This guy gonna have only 1 unpair, and the rest of the lone pair. So 7 electron total. That's why the bonding capacity is 1. Okay. So iodine, same thing, group 7. So 7 valence electron. Bonding capacity going to be just 1. Need 1 more electron to become octet. So 1 unpair, the rest of the lone pair. All right. Silicon. Silicon is right below carbon. So group 4. All right. So bonding capacity is 4, which means that the silicon will need 4 unpaired electrons around it. So each one will form 1 bond. All right. Sulfur, group 6, so 6 valence electron. Need 2 more to become octet, so bonding capacity is 2. All right. So sulfur will need 2 unpair, and the rest are the lone pair. Now potassium, group 1. Group 1, 1 valence electron. Well, the bonding capacity depends on how you look at it. So potassium does not form a covalent bond. Remember that, right? So because that 1 electron here, this lone electron will be lost. So potassium just take 1 my electron. I don't want it. So if you think about the covalent bond, is potassium doesn't form covalent bond, but if you want to count the ionic bond, just 1, right? So potassium has only 1 unpaired electron. Argon, so group 8 valence electron. Does this guy want to form bond? No, argon is one of the inert gases, right? That's the reason why argon, 8 electrons here exist as lone pairs. All right. So Lewis symbol is really important because we're gonna use this Lewis symbol to draw Lewis structures. Take a look at the next video. Okay.